Namaskara. Welcome to the last lecture of 18 Mat 31 Engineering Mathematics 3 third module of VTU under the E section of VTU. I am PR Hampioli, Head Department of Mathematics KLS JAT Belagavi. So last class we learned the inverse jet transformations. Using that knowledge, we'll be solving differential equations, but in discrete terms, they are termed as difference equations. So today in the 12th lecture of 18 Mat 31, third module. So we are continuing with jet transforms. The full module consists of two transforms, Fourier transforms and jet transforms. First 6 lectures are Fourier transforms, 7 to 12th are jet transforms. So today we are here to learn solution to difference equations. Solutions to difference equations. So here we go without wasting much time. In difference equations in a nutshell, suppose you know some un value, then you can find un plus 1, un plus 2 and so on. Then there can be a connection between all these, like 2 times plus 3 times equal to some n square, and you may be given some u0 and u1 value initial conditions like 1 and 0. If so, what is un you have to find, or if so, how to solve this equation consisting of un just like difference equations. So let us start with the first example. Solve the difference equation connection is un plus 2 n plus second term plus 4 times un plus 1 plus 4 times un equal to some number 7. We are also given that given initial conditions we can call u0 value and u1 value is 2. So our aim is to find what is un. So in the solution part, what we start is, so though it may be repetition, I will write, we are given some difference equation, un plus 2 plus 4 times un plus 1 plus 4 times un equal to 7 with u0, u1. Now, if I apply z transforms on both sides, z transforms, okay, apply z transform on both sides. Just like you differentiate both sides, integrate both sides, multiply both sides, apply z transform on both sides. The z transform of first function plus 4 times linearity property, z transform of second function plus 4 times z transform of un equal to z transform of 7. Now we use the right shifting property, left shifting property. Using shifting property, first term becomes z square into bracket u of z minus u0 minus u1 by z. Second term becomes plus 4 times, if I can write here, one below another, 4 times this one, z into u of z minus u0. Third term is plus 4 times u of z. Is all equal to right hand side. Z transform of 7 is 7 into z by z minus 1. Now what we do here is we substitute the values of u0 and u1, where we have noted that u0 value and u1 value are given. So u0 and u1 values are given. So not to get confused with this. u0 is 1, u1 is 2. So wherever u0 is there, you have to put z equal to, u0 is there, you put z equal to u0 equal to 1 and u1 equal to 2. So this becomes, put u0 value, u1 value, u0 is 1, u1 is 2, as I told, 1, 2 here, and here also 1. So how it looks like now? Z square into bracket u of z as it is, u0 is 1 minus 2 upon z, plus, purposely I am writing one below the other, 4 times z, u of z as it is, u0 is 1, plus 4 times u of z. This is our left hand side, right hand side as it is. So now we are going to find what is u of z first. Then if I find u of z, I can find un by taking inverse z transform. So our aim is to find what is u of z. That u of z is here. So shall we collect that u of z? So z square plus 4z plus 4 into u of z. So what we did, dear students, first we collected all the z square terms. Then remaining terms we multiply inside. What you will get? Minus z square minus 2z minus 4z. So here 1, 2, 3 terms, right hand side as it is. So this becomes z plus 2 whole square into u of z equal to 7 times z by z minus 1. I transfer this all negative terms to the right hand side, plus z square plus 6z. Our aim is to find what is u of z. Before that, right hand side first I'll simplify, keeping z plus 2 whole square as it is. To simplify this, first z is common everywhere. Let me write 7 by z minus 1 plus z plus 6. So still right hand side can be simplified. So this is equal to z into bracket 7 plus z square minus z plus 6z minus 6. So if you simplify this, whole divided by z minus 1 as it is. So again, right hand side, if you simplify still further, z into bracket, z square term is there. How many z terms are there? 6 minus 1. What is the constant term? 1. Z square plus 5z plus 1. This divided by z minus 1. Now we are ready to transform z plus 2 whole square term to find only u of z equal to z into z square plus 5z plus 1 whole divided by z minus 1 into z plus 2 whole square. But it is a customary to find. Okay, first of all you have to make it z cube term is there here also, z cube term is there also. To make it partial fractions, numerator should be less than denominator, as in power. Power of numerator, highest power of numerator less than highest power in denominator. Also for u of z, usually it is better to find u of z by z becomes z square plus 5z plus 1. This type of things you did in inverse z transforms. Now onwards it is simply inverse z transform, z minus 1 z plus 2 whole square. So let us apply the partial fractions rule. A by first factor, b by z plus 2, because it is repeated, c by z plus 2 whole square. Now if I find ABC using only this part, that is multiply by the denominator, of this. So what I get? Some equation star I am going to get, which is z square plus 5z plus 1 equal to a into z plus 2 whole square plus b into z minus 1 into z plus 2. And such things we have done. We will not waste much time for this, but I will give the hint. To find a, see here z minus 1 is common, put z equal to 1, you will get a. So let us call it as star equation. Put in star following operations, put z equal to 1. So you'll get 1 plus 5 plus 1. Okay, 1 plus 5 plus 1. Here you are going to get 1 plus 2, a into 9. So you will end up with the value of a as 7 by 9. Second one. Very similarly, you can see that z plus 2 is common, so that you can get the value of c by put z equal to minus 2 in star. So that you are going to get 4 minus 10 plus 1 equal to 0 plus 0 plus c into minus 3. So this implies certain value of c. We can very easily verify that c is nothing but 5 by 3, because you are going to get minus 10 plus 5 minus 5, and here minus 3 minus 5 minus 3, so it is plus 5 by 3, plus 5 by 3. So to find the remaining b value, you can select some value for z here. Z equal to 0 is the best value. For b, put z equal to 0. You are going to get z equal to 0 here 1 equal to. So you are going to get 4a minus 2b, because z equal to 0, and z equal to 0 minus c. Except b remaining values we know, so that this will yield us the value of b as 2, which I am not done, because a equal to 7 by 9, c equal to 5 by 3, you can substitute. Substitute a equal to 7 by 9, b equal to 2, c equal to 5 by 3 in this equation 1. So you will get u of z by z. So shall I write that as put the values of a, b and c in 1. So u of z by z now looks like this: a by z minus 1, 7 by 9 into 1 upon z minus 1, b by z plus 2 upon z plus 2. Okay, and c is 5 by 3 into 1 upon z plus 2 whole square. Now if I transfer this z also this side, almost all we are going to get in a perfect shape of inverse, ready to take inverse, except the last one, which we shall adjust it, z by z plus 2 whole square. So looking to this last term of this, z inverse of u of z, 7 by 9 times z inverse of z by z minus 1 plus 2 times z inverse of z by z minus of minus 2 plus here you have to make observation that this is z minus of minus 2 whole square. So whatever is minus 2 is here, you multiply to this z, but when you multiply you have to divide also. Okay, so what you did, you multiplied and divided by minus 2 here and minus 2 here. So why we did that? Because to get un, 7 by 9 times 1 raised to n becomes 1 plus 2 times minus 2 raised to n minus, because 6 here, minus 5 by 6 times. This is actually the value of z inverse of n. So everywhere z inverse, this is also z inverse of this, but because of minus 2 multiplication, you have to write minus 2 raised to n. So now, given some difference equation, what we did, quickly you see, we applied z transform. We applied now in the next this one we applied. Therefore this is the first step. Second step, we applied shifting theorem. This becomes z square into, this becomes z into, this is u of z. Right hand side, z transform of a constant is constant into z by z minus 1. Using the value of u0, u1, you will get first u of z terms and non-u of z terms. So you simplified on the right hand side till you get a perfect shape. Then you took u of z by z and partial fractions ABC. When you do partial fractions, all are in a perfect shape except the last one where minus 2 we need to multiply to bring it to the standard form. Next one, find the z, solve the difference equation. Solve the difference equation. Un plus 2 minus 3 times un plus 1 plus 2 times un equal to 0. Right hand side is 0 here, where u0 is 0 and u1 equal to minus 1. Sometimes the same question is asked like this in communication theory language. Same questions, or I'll write or find the system response. Find the system response if it follows the rule 3 times un plus 1 times un equal to 0 with the given condition. Same question asked in a different fashion. So u1 equal to minus 1. So that you have to find u2, u3, u4, u5 and so on. Now method is same. In the solution part, what all we would like to write? Given the solution part. Okay, we are given this difference equation un plus 2 minus 3 times un plus 1 plus 2 times un equal to 0 with these conditions. Now apply Z transform. First we apply Z transform and afterwards inverse Z transform. Z transform of, we apply Z transform of un plus 2 minus 3 times Z transform of un plus 1 plus 2 times Z transform of un equal to Z transform of 0 is 0. So this becomes z square into bracket u of z minus applying shifting theorem u0 minus u1 by z. So purposely I am writing one below the another so that you can collect u of z terms very nicely. Minus 3 times z raised to 1 into bracket u of z minus u0. Last one plus 2 times u of z. Right hand side 0. Now we have to substitute the values of u0 and u1. u0 and u1. So what is the value of u0 given? u0 is nothing but 0. So put u0 is 0 and u1 equal to minus 1. So what all we are going to get if at all we put u0 equal to 0. If I put wherever u0 is there 0 here, 0 here and minus 1 here, I am going to end up with, okay, z square into bracket u of z minus 0 minus of minus 1 upon z. Second term minus 3 times z into bracket u of z minus 0. Third term plus 2 times u of z, right hand side 0. So naturally we are left with z square u of z terms. Let us collect u of z terms first. Z square minus 3z plus 2. These are all u of z terms. So minus of minus plus, if you multiply z square inside here, it becomes z square by z becomes z. Sign is minus of minus plus equal to 0. Now except u of z terms, remaining terms if I transform, I am going to get z square minus 3z plus 2 into u of z equal to minus z. Or if I interchange these two, I am going to get u of z by z, okay, is or minus of this is equal to 1 upon z square minus 3z plus 2. The right hand side is very simple case. So minus of u of z by z. So factors are 1 upon z minus 1 upon z minus 1, 1 upon z minus 2. Let us break into partial fractions a by z minus 1 plus b by z minus 2. Now only this part, if you look, you can very easily find a and b value, which I will show you now again, which is repetition for inverse z transform. U of z by z therefore equal to find a value, put z equal to 1 here and neglect this part, neglect z minus 1 part. So 1 upon 1 minus 2 upon z minus 1 plus, for b value you neglect z minus 2 part and put z equal to 1, z equal to 2 in the remaining factor 1 upon 2 minus 1 upon z minus 2. So this gives us minus u of z by z equal to, first term becomes negative, second term becomes positive. But if you cancel this minus z, if you take this side, simply u of z if you retain on the left hand side, we are left with the first term as positive, second term as negative. This is the perfect shape of inverse transform. Taking our final aim is to find what is un. So first we transform to u of z and take the inverse transform. So taking inverse z transform, z inverse of u of z equal to z inverse of first term minus z inverse of second term. So get familiar to all this. This z becomes n term, this becomes 1 raised to n means 1, and this becomes 2 raised to n. So nice corresponding solution of the difference equation un equal to 1 minus 2 raised to n. Now how do you check this? If you put n equal to 0, you will get u naught. U naught equal to 1 minus 2 raised to 0. 1 minus 2 raised to 0 means 1 minus 1 means 0. So u naught is matching. If you put n equal to 1, you will get u1. 1 minus 2 raised to 1 means 1 minus 2 equal to minus 1. So that you will get back the values of u naught u1 using the system. So very similarly, now once you transform into the partial fraction language, it is nothing but inverse transformations. Once you transform into the partial fraction language, it is nothing but inverse transformations. So now you are going to get similar examples. Only thing is how we find the partial fractions is more important. Right hand side you will be left with some z function, left hand side usually u of z by z, whether they are repetitive factors or whether they are non-repetitive factors, linear factors, depending on that you have to think natural partial fractions. So here 50% of that is mainly partial fractions and inverse z transform. Given an equation in un plus 2, un plus 1, un with some conditions u naught u1. If u naught u1 are not given, the final answer will remain in terms of some constants. So if they are given, we will get exact un. First you take z transform, convert n to z function, and afterwards u of z when becomes perfect shape, you transform in terms of again z inverse you take. So we will continue with the next example. Solve difference equation yn plus 2. Instead of u, let us use some different symbol, minus 5 times yn plus 1 plus 6 times yn equal to 1 with the conditions y0 and y1 like this. Now in the solution part, consider the given differential equation, that is difference equation y n plus 2 n plus 1 term, n term apply z transform. So to each term of this you have to go on writing z of minus 5 times z of plus 6 times z of yn. Right hand side we should never forget z of constant equal to 1 upon z by z minus 1. So now first term, applying shifting theorem, z square yz minus y0 minus y1 by 2. Second term, minus 5 times z into yz minus y0. Third term, 6 times y of z. This is all left hand side. Right hand side, z by z minus 1. Now remains is we have to substitute the values of y0 wherever y0 is there, 0, wherever y0 is there, 0, y1 is there, 1. Let us first do that using y0, y1. Now the equation looks like this: z square y of z minus 0 minus 1 by z minus 5 times z into bracket y of z minus 0 plus 6 times y of z equal to right hand side as it is. Now if we simplify, first taking yz terms into account, that's why we write one below the another, which will help us to write, see, yz terms, these yz terms you collect. So that is z square minus 5z plus 6 and remaining as it is, which is what happens is when I substitute, when I multiply z square, inside here minus z is generated, remaining all 0 terms and right hand side remains. So first let me factorize this as z minus 2, z minus 3. So we should not forget that to find yn, we are finding first y of z, then taking inverse transformation. Our ultimate aim is yn. So right hand side, z by z minus 1 plus z terms from left hand side borrowed. So now, therefore, next z minus 2, z minus 3, y of z. If I take z common, it looks like this. Now if I simplify, keeping left hand side as it is, if I simplify the right hand side, so z minus 1 here, z by z minus 1. Now what I'll do is I'll transfer this to the left hand side, I'll transfer these two to the right hand side. See how we are going to get y of z by z. So y of z by z, therefore y of z by z looks like this: z by z minus 1, z minus 2, z minus 3. A very straightforward partial fractions can be written as a by b by c by. And several times we discussed how to find ABC. Let us see once again, no problem at all. So we are finding y of z by z. So we are going to find A, B, C values, but first let me keep ready this structure. To find A value, what all you have to do is, this z minus 1 you should leave here, and in the remaining part, wherever z is there, you put z equal to this one, z equal to 1. What happens? 1 upon 1 minus 2 is minus 1. 1 minus 3 is minus 2. In a similar way, in a very, very similar way, to find b value, this z minus 2 you have to leave, and in the remaining part you put z equal to 2. So z equal to 2, if you put 2, 2 minus 1 and 2 minus 3. Similarly, except z minus 3, in the remaining part you put z equal to 3 for c, 3, 3 minus 1, 3 minus 2. So our y by z by z, y of z by z is ready. A is 1 by 2, B is minus 2, and C is 3 by 2. Remains is to transfer this z right hand side and retain y of z. Exactly perfect shape of inverse transformation. We can take plus 3 by 2 times z by z minus 3. So taking inverse z transformation, z inverse of y of z equal to z inverse of each term, z inverse of first term minus 2 times z inverse of second term plus 3 by 2 times z inverse of third term. So everything we are transforming now in terms of n term. At last yn equal to half of, this is 1 raised to n or 1 minus 2 times 2 raised to n plus 3 by 2 3 raised to n becomes our final answer. So very, very similarly, with little change, we need to study some more examples. Here we go for the next example. So that is getting used to, we are getting used to the language of difference equation. Solve to find un plus 2 plus 4un plus 4un plus 1 plus 3un equal to 3 raised to n. See that right hand side, sometimes 0, sometimes constant, sometimes some function of n with conditions u0 and u1. The same example sometimes can be written as find the system response if this happens. This is our equation star, suppose if this happens. In both the cases we have to find what is un. In differential equation we find dy by dx plus y equal to e raised to minus x. At last we find what is y equal to. Similarly here what is un equal to we find. Now in the solution part, first let us consider given. First write properly the given difference equation. N plus 2 term, n plus 1 term and n term. Properly right hand side. Taking z transform of first term plus z transform of second term plus z transform of third term equal to right hand side also z transform of right hand side. Using shifting theorem, this looks like uz minus u0 minus u1 by z. So if you write one below the other, it is useful, it is not compulsory. Plus second term plus 4 times z into, because of shifting theorem it becomes z into u of z minus u0 plus 3 times u of z, right hand side z by z minus 3. Now we have to substitute the proper values of u0, and u0 is 0 and u1 is 1. So this I have not written here, with u0 0 and u1 1. So 0 here, 1 here, 0 here. Next step is, so therefore Substituting u0 u1 values, u of z minus 1 by z plus 4 times z into u of z plus 3 times u of z equal to z by z minus 3. Now if you simplify this, first considering all u of z terms, z square plus 4z plus 3 into u of z, right hand side, if you transfer this minus z term to the right side, you are going to get z plus z by z minus 3. So factorization of this is z plus 1, z plus 3. And right hand side, if you take z common and simplify, 1 plus 1 by z minus 3 looks like this. Z into z minus 3 becomes z minus 2 upon z minus 3. So we are after u of z. So this was left hand side was therefore z plus 1, z plus 3 u of z. Now it is very clear that you should find u of z by z equal to what? Equal to, naturally it is z minus 2 divided by, so some 3 factors which I can write, z minus 3, z plus 1, z plus 3, which are linear factors, which can be written as a by z minus 3 plus b by z plus 1 plus c by z plus 3. With the usual fashion, if you find a, b, c, which I would like to give the values of a, b, c, a you will get 1 by 24, b you will get 3 by 8, and c you will get minus 5 by 2. So what is the meaning? At last, u of z, we are going to get, transferring z this side and putting ABC values also, 1 by 24 times z by z minus 3 plus 3 by 8 times z by z plus 1 plus minus 3 by 2 times z by z plus 3. They are in the perfect shape of taking inverse transformation. So with some liberty, let me write un directly, which is 1 by 24, 3 raised to n, 3 by 8, minus 1 raised to n, and minus 3 by 2, minus 3 raised to n. This becomes un. That is the solution of differential equation or difference equation. Next example. Solve yn plus 2 plus 6 times yn plus 1 plus 9 times yn equal to 2 raised to n with y0, y1 both zeros. So if I apply z transform of applying z transform, that is, this is the first step. Consider this equation. With some liberty, I am taking some steps directly. Z transform of first term plus 6 times z transform of second term. So 9 times z transform of yn equal to z transform of 2 raised to n. So we are trying to get used to it using shifting theorem, z square yz minus y0 minus y1 by z plus 6 times z into yz minus y0 plus 9 times yz equal to right hand side z by z minus 2. Now we know that all these values are y0 0, y1 0, y0 0. So if I utilize that to frame the next equation, z square plus 6z plus 9 of y of z equal to z by z minus 2. So here y of z by z is very clear. This becomes z plus 3 whole square and right hand side as it is. Now y of z by z, if I find, it looks like this, 1 by z minus 2 z plus 3 whole square. So if I split that into partial fractions, I can write like this also, a by z minus 2 plus b by z plus 3 plus c by z plus 3 whole square. So this we shall use to find ABC values. We have to multiply by the denominator of this, which is 1 equal to a into z plus 3 whole square plus b into z minus 2 z plus 3 and c into z minus 2. So choosing proper values and coefficients and all that, we are, for example, if I put z equal to 2, I am going to get z equal to, I am going to get a. If I put z equal to minus 3, I am going to get b. And after putting z equal to 0, I am going to get c. So a value you will get 1 by 25 directly, because you see this value z equal to 2, z equal to 2, z equal to, this is becoming 0, z equal to, this is becoming 0, 2 plus 3, 5, 5 square is 25, a is 1 by 25. In a very similar fashion, b value you are going to get minus 3 and c value minus 1 by 5. So substituting these ABC values as 1 by 25 and so on, what is finally y of z by z we get is 1 by 25 times 1 upon z minus 2 minus 3 times 1 by z plus 3 minus 1 by 5 times 1 by z plus 3 whole square. Here everything is perfect, but one small adjustment we have to do. Before that, let me write what is y of z by z. 1 by 25 times z by z minus 2, no problem, this is perfect. Minus 3 times z by z plus 3, no problem. Minus 1 by 5 times, here there is small adjustment is required, because it is not raised to 1, and that adjustment is, this is should be considered as minus of minus 3, so that we require minus 3z to be multiplied and minus 3 to be divided here to make it perfect inverse transformation. So taking inverse transformation, 1 by 25 times 2 raised to n minus 3 times minus 3 raised to n, so that the last term, this becomes plus 5 c equal to, actually we get here 5 and this becomes plus 5 by 3 times, this is nothing but n actually, but multiplied by minus 3 raised to n into n. So this becomes the final answer for this. So before we go to the next examples, please practice very similar examples, which is the first one. Suppose I write un plus 2 minus un plus 1 plus 6 times un equal to 2 with conditions u0 and u1. The answer should be for this un equal to 2 plus 2 raised to n. Second one of the similar kind, un plus 2 minus 2 times un plus 1 plus un equal to 2 raised to n with some initial condition u0 and u1, and answer for this should be un equal to 2 raised to n plus 1 minus 2n. So these are the some examples where there is lot of things common. And before I proceed to the last example, dear students, we have discussed so many concepts in Z transformations. I am coming to the last example. Before that, please see that you practice all the examples which are taught properly. And before I end, there is a small one example where some changes are there. This will take some 5 to 10 minutes. And afterwards, we shall say bye. And you please read all the 12 lectures which are done. Last example, little bit carefully, this example. Suppose we are asked to find a difference equation of the type un plus 2 minus 2 times un plus 1. In this example, a small change is there. That's why I am taking this 3n plus 5. So we are not given any u0, u1 value. First change. Then if I take the z transform on each term, what happens? Minus 2 times z transform of un plus 1 plus z transform of un equal to z transform of the right hand side. Now this becomes z square uz minus u0 u1 by z as usual. This becomes plus 2 times z u of z minus u0 as usual. And this becomes u of z as usual. Right hand side 3 times z by z minus 1 whole square plus 5 times z by z minus 1. So a little bit involved. So here u0 and u1 are not given. We have to keep as it is. So with little care, if I write z terms, it is therefore z square plus 2z plus 1. This becomes u of z term. Remaining are minus u0 z square minus u1 z and minus 2 times z u0 equal to right hand side as it is 3 by z minus 1 whole square plus 5 times z minus 1. So now, I think this is a minus sign. So let us keep this also as minus sign. This becomes a minus. So this becomes plus 2z u0 plus 2z u0. Now, needless to tell that this becomes z minus 1 whole square u of z equal to right hand side. If I transform all the functions 3z z minus 1 whole square plus 5 times 5 by z minus 1 plus u0 z square and u1 z terms, you can definitely write it as u0 z square minus 2z minus u1 z. So these terms you transfer u1 z, u0 z square minus u1 z plus 2 times z into u0. So what all we did? Z square minus 2z plus 1 into u of z minus u0 z square minus u1 z plus 2 times z into u0. So if you multiply this inside, you are going to get these terms. And when you transfer all these terms to the right hand side, what you are going to get at last? U of z can be written as, if you simplify a bit, 5z square minus 2z upon z minus 1 raised to 4. This is one term plus all u0 terms. See, here also one u0 term is there, here also one u0 term is there. So all u0 terms, if you transform z square minus 2z, so z square minus 2z, so this here to here it is better to see z square minus 2z upon z minus 1 whole square. Similarly, only one u1 term is there, that becomes plus u1, z is already there, again z minus 1 whole square. So we are not much worried about. So directly inverse transform, we get un. First I will find the consider u0 term. Suppose u0 term, z square minus 2z upon z minus 1 whole square can be rearranged as z square minus z upon z minus 1 whole square, which is z into bracket z minus 1 minus z upon z minus 1 whole square, and separating the terms we are going to end up with z by z minus 1 minus z by z minus 1 whole square. And this term is directly ready to take the transformation, which is u1 term is already ready. So z by z minus 1 whole square, as it is you can keep, as it is you can keep. That is the inverse transformation of this is n. So this becomes un is n. Inverse transformation of this is n, and inverse transformation of this is 1 minus n. So let us keep that in mind. Now my concern is this part. For this part there is a special treatment. You should write 5z square minus 2z upon z minus 1 raised to 4. See, what you can do is, this is the maximum power, next power. This type of treatment you have not done in the previous example. Z minus 1 whole square till z minus 1 raised to 1 you can write. And what all you have to do is a into b into c into d into. But do you remember what is that exact formula for when raised to 4 was there? It is a z cube plus 4z square plus z. Here z square plus z. Here z and here also z. We are arranging in such a way that this A, B, C, D constants have to be found under these conditions. And if you cross multiply this denominator everywhere and find A, B, C, D values, because that part I am leaving it to you, A equal to half, you will get what you have to do, cross multiply this and go on substituting, taking the coefficients, different coefficients, Z equal to A equal to 1 half, B equal to 1, C equal to minus 3 by 2, and D equal to, you are going to get 0. Okay. So substituting all these values and taking inverse transformation, see that you will end up with half, because A is half n cube, B is 0, B is 1, so this becomes n square, 1 into n square. C is minus 3 by 2 into n. So that constant term is not there, leave it, and remaining part u naught into term is this term, which should be written as plus u naught into term, that is z by z minus 1 becomes 1, and next one is n, and u1 term plus u1 into plus u1 into, you can very easily recognize what is the u1 term here. Z by z minus 1 whole square is n. So if the coefficients, if the conditions are not given, this becomes the final answer. Dear students, so far we got different type of examples in Z transforms, Fourier transform, Z transform. Finally we ended with the solutions of difference equations. My earnest suggestions and request to you is, take pen and paper and always study. See, u0 and u1, they were not given, that's why they remained the same. See that you practice all these examples, practice some more examples of referred books. So here I sign off for Fourier transform and Z transform. If at all you have got some queries, always you can mail me pr.hampiholi@git.edu. See you. Bye. Wish you all the best.